Ask My Instructor 10.3.13. In this problem, we have three tasks. Find the first three non-zero terms of the Maclaurin series for the given function. Write the power series using summation notation. And lastly, determine the interval of convergence of the series. Let's start with a short review. Suppose a function f has a derivative of all orders on an interval containing the point x equals a. Then the Taylor series for f centered at a is defined to be this power series. Notice that a Taylor series is just a Taylor polynomial with an infinite number of terms. If a equals 0, then the series is called a Maclaurin series, and the derivatives will be evaluated at 0, and x minus a just becomes x. We want to find the Maclaurin series, so we're going to be evaluating our derivatives at 0. We want to find enough terms that we see a pattern and can make a generalization. And I think it is a good idea to not simplify until you see that pattern. That helps with step B. So even though we're doing step A, we want to keep step B in mind. And I like to make a table to help me keep my information organized. So first I find all the derivatives, and I find as many derivatives as I need until the pattern becomes fairly obvious. So these are my derivatives, and then next I'm going to evaluate the derivatives at 0, and after I do that, I'm ready for my last column. Now, resist the temptation to simplify. It is after I find my generalization that I simplify. So now that I have my general term, I simplify it, and I simplify it so that I can answer step A in for my math lab. However, doing it the way I did it, I've also answered step B. So the green gives me step A, the red gives me step B, and this is what I have. Hold on, let me fix this. Okay, that looks better. I had a little typo and I just fixed it. All right, so my next step is going to determine the interval of convergence. So let's go ahead and find that interval of convergence. To determine the interval of convergence of the series, we look for absolute convergence using the ratio rule. You can use any rule you want, but I like the ratio rule. So let's set that up, and we're looking for absolute convergence. And the first thing we do is find the radius of convergence, and then that'll help us find the interval of convergence. All right, so set up your ratio. That looks pretty ugly. How about if we flip and multiply? Flip and multiply, and this is what we get. Now, you might be asking me, how did you get that? Well, 3 to the k plus 1 over 3 to the k is just 3, and that's positive, so I bring it outside the absolute value sign. K factorial over k plus 1 factorial is 1 over k plus 1. It is also positive, so I bring it also outside of the absolute value sign. X to the k plus 1 over x to the k is x. Now, x can be positive or negative, so it stays inside the absolute value sign. And now that we have the ratio, we're ready to find the limit. So let's find the limit as k goes to infinity. Now, last time I checked, 3 does not care what k is doing. K can do whatever it wants, and 3 is just going to keep being 3. Same thing with x. X is any number, but still x does not care what k is doing. Now, somebody who does care what k is doing is 1 over k plus 1. As k gets larger and larger and larger, 1 over k plus 1 is getting smaller and smaller and smaller, and so at the limit we would get 0. Now the limit of the ratio is equal to 0, and that did not depend on the value of x. Remember we said x could be anything? So we have that the ratio rule condition for convergence is satisfied for all values of x. And the radius, that means that the radius of convergence is infinity, meaning that the interval of convergence would have to be negative infinity to infinity. Any x value, I will get that ratio of 0. So we've got our first three positive non-zero terms. We have our summation, and we have our interval of convergence. We're all done. Take care. Have a great day.